Right now, your brain is aging and so is mine. Like all other organs in our body, our brains are getting older and changing. But the brain has significant differences to other organs in our bodies. Brain cells do not renew themselves. They cannot divide, and our ability to generate new ones is limited. So once we reach adulthood, we have pretty much all the brain cells that are going to get us through our whole lives.
What is amazing, though, is how many cells there are and how adaptable they are, giving us enormous extra capacity for learning things and for coping in case something goes badly wrong, such as an injury or stroke. The adult brain has around 10 billion brain cells, far more than we can ever fully use. And whereas the adverse effects of aging are relatively easy to see elsewhere in the body, brain cells are much more resilient.
So the brain is an amazing asset in its extra capacity, its adaptability, and its resistance to the aging process. Of course, aging does eventually take its toll on brain cells. Most of the studies of aging have focused on memory. Psychologists have identified two distinct types of memory: primary memory and secondary memory.
Primary memory relates to short-term storage of information, such as remembering the name of someone you have just met. Secondary memory relates to long-term storage of information, such as remembering the name of someone you have known for many years. In primary memory, you have to repeat or rehearse the information or you'll forget it. As we revisit this information and turn it over in primary memory, it gradually seems to find a place for itself in secondary memory. Secondary memory is the ability to call up information that is held somewhere in long-term storage. It's like retrieving a reference book from a library shelf deep inside your head. Somehow, your mind seems to know where to go to find it. These secondary, long-term memories are generally the most secure and easiest to retrieve, especially those from early adulthood. But also, throughout our lives, we are adding to our store of knowledge, skills, and ideas that are held in our long-term memories.
From midlife onwards, primary memory, that is short-term memory, becomes less reliable. People find it harder to remember things like new names or new phone numbers. But on the whole, memory does not change so much in later life, except where people get some kinds of diseases. We'll look more at these diseases and their effects on memory shortly.
In some ways, aging has a more noticeable effect on our cognition than it does on memory, and by cognition we mean thinking. Most studies agree that aging slows us down. It slows down the speed of thinking, and it slows down our reaction times. The research also shows that aging makes it harder for us to switch easily from one task to another.
So as our brains age, there is a slight impairment of primary or short-term memory, but our thinking gets slower and we find it harder to switch from one task to another. None of us can escape aging and the changes that aging causes. These changes are normal and natural, but sometimes they appear very similar to changes that are caused by damage or disease. Researchers face a challenge in trying to decide what is normal aging and what is not. For example, some of the diseases that cause memory loss are very common, and they can be present for years, perhaps decades, and the symptoms can be very mild in the early stages. So it can be impossible to tell the difference between one person whose cognitive decline is caused by the early stages of a disease and another person whose decline is entirely normal.
We have seen how aging brings about a decline in memory and cognition, and how this decline can be similar to the effects of disease. But aging is not all bad news. As we age, we are also building up a huge store of learning and life experience. We call this crystallized intelligence. Crystallized intelligence helps us to function very well as we get older.
So as we get older, we can expect to get a bit slower and to find it harder to switch from one thinking task to another. We become less flexible in our minds, but in the absence of disease, we do not have any significant memory loss. And thankfully, crystallised intelligence goes a long way to compensating for the effects of ageing. The knowledge and wisdom it gives us means that the old person's mind functions just as well as the young person's mind. So we've seen how the normal processes of ageing can result in a gradual decline in memory and thinking. Where there is disease, this process can be dramatically speeded up. Dementia is the general term that is used to describe a decline in brain function that is not normal.
A person with dementia experiences significant problems with their thinking and memory, particularly short-term memory. This makes it harder to do normal things and eventually leaves them very confused and unable to function. Dementia is extremely common. In the UK, there are 700,000 people with dementia, and this number is getting bigger all the time as more people live to be elderly. Around 5% of people over 60 have dementia. For those aged 85 and over, that figure rises to more than 20%. Some studies show figures as high as 50%.
By the year 2025, there will be more than 1 million people living with dementia in the UK alone. This represents an enormous cost, most obviously to the affected person who loses their memories and independence, but also to their families. Dementia has been described as a living bereavement. It's as though the families have lost the person that they've known and loved.
Dementia also represents an enormous cost to the economy. Estimates are that in the UK, the cost is over £17 billion per year.
Dementia is caused by a large number of diseases. The most common of them is Alzheimer's disease. Up to 2/3 of people with dementia have Alzheimer's. Despite all our efforts, the precise cause of Alzheimer's is not yet known, but we do know that genes play a small part. This means that if a person has a parent with Alzheimer's, they may have inherited a gene that marginally increases their chances of also getting the disease.
Having a gene that is associated with the disease does not mean that a person will definitely get the illness, only that they are slightly more likely to do so, and then only if they live to be elderly.
We know less about the non-genetic causes of Alzheimer's disease, but mental and physical activity appear to be important protectors.
Eating a healthy diet and doing exercise will help to keep your heart and arteries in good condition. Education, when you are young, also offers some protection. The most famous study to show this resulted from an order of nuns who agreed to donate their brains to medical research. Scientists found that their level of education when they entered the convent was clearly related to the amount of Alzheimer's disease in their brains some 60 or 70 years later. No one really understands why this is, but it's plausible that training the brain when it's young makes it better equipped to cope with damage late in life. Being socially active rather than isolated is also thought to be protective.
So the best advice today, if you want to avoid Alzheimer's disease, is eat a healthy diet and be active physically, mentally and socially. Alzheimer's disease is named after the German doctor, Alois Alzheimer, who worked in the early 1900s. He studied the case of a female patient who was suffering from a progressive loss of memory along with paranoia and delusions. She gradually lost all her ability to look after herself and then died.
Dr. Alzheimer performed an autopsy and found 2 unusual features or lesions in her brain. He called these plaques and tangles. We now know much more about what these are and how they are formed. Plaques are large accumulations of a protein called amyloid outside of the brain cells or neurons. This amyloid is sticky and clumps together. Other proteins also stick to it. To protect itself, the brain reacts with an inflammation. Unfortunately, this inflammatory reaction probably contributes to the damage in the long run. The tangles that Dr. Alzheimer noticed are called neurofibrillary tangles. They are also a build-up of protein, but unlike the plaques, the build-up occurs inside the neurons and is formed from a protein called tau. The tau protein is essential for the normal functioning of the neuron. It is part of the structure of the axons, and it allows essential components and waste products to be trafficked up and down the neuron. But in Alzheimer's disease, the tau protein ceases to function in the normal way and accumulates in the neuron in tangles. This leads first to the neuron not working and eventually to its death. Lose too many neurons and the brain cannot compensate enough, and the result is memory loss and other symptoms of Alzheimer's disease.
We're beginning to understand how the tau protein turns from a beneficial protein to a toxic one, and we are starting to design treatments that might prevent, perhaps even reverse this process. We're also beginning to design drugs to prevent the build-up of plaques. These advances bring hope for a major breakthrough in the next 5 to 10 years.